and start recording. So last few class periods, we learned that, hey, if two lines are parallel, right? Parallel, going in the same direction, what do we know about their slopes? What do we know about slopes of parallel lines? They have the same slope, right? Because they're going in the same direction. So the rise over the run for this line is going to be the same as the rise over run for that line because they're increasing at the same rate. So if the slope of this line is, let's say, 2/5, then that means the slope of this line is also going to be 2/5, right? If they're parallel. So parallel lines are going to have the same slope. We also learned about perpendicular lines. What do we know about perpendicular lines? Perpendicular. Right? We know that their slopes are what? They're not the same, right? Because they're not going in the same direction. So they are opposite reciprocals of one another. So like, let's say this slope is, I'm just going to say it's 4. Okay. The opposite reciprocal of 4 is 1/4 or -1/4, right? Multiply by -1. So if this slope is +4, this slope is going to be -1/4. Okay, so perpendicular lines have opposite reciprocal slopes. Parallel lines have the same slope, right? So that's just kind of a review of what we've been doing, what should appear on your next test or final exam or something like that, okay? So let me clear that writing right there. And now we're going to go to, so today's lesson, we are actually doing a bunch of lessons in one. We're doing 321, 322, and 323. Okay, so you're going to take notes. We got a lot of notes to take today. We're going to do 84 through 87 and 97 through 100, skip 86. So you're going to submit these notes for 15 points credit because since this was a big assignment, I made it 15 points. And then for your homework, you're only going to have a Delta Math assignment. And that's it, nothing from the book. So the Delta Math assignment, there are, I think, like 6 problems. You are required to get each of the 6 problems right 3 times. And they're very easy problems, guys. I was doing them this morning. I was like, whoa, this is way easy. And you get 6 attempts, I believe, or 2 attempts at each problem. So you get 6 total attempts. If you need them, you don't need them all, then you don't need to take them all. So you need to get the 6 problems right 3 times. Like I said, it's a super easy assignment. I mean, you should finish that in like 10, 15 minutes. Okay, so I put the link to Delta Math here. Answers to your homework. Okay, so the answer to this guy right here, the first page, this triangle is going to move down 3 units over here. This quadrilateral is going to move to the left and up 3 units and look like that. For number 3, it looks like that. For number 4, this one looks like this. 5 looks like this. 6 got moved over here. For 7, the rule x minus 6, y minus 7. 8, x minus 1, y plus 6. 9, x minus 3, y minus 3. 10, x minus 1, I think it's y minus 2 is what's supposed to be over here. 11, here's your picture for 11. Here's the coordinates. If you need them, it's attached to the homework so you can see it. 12, here's the image. Sorry, the coordinates got cut off, but they're pretty easy to figure out from the picture. And 13 looks like this. It's right over itself. It's not exactly the same. It's in the blue right here. And the rule is x comma negative y minus 2. Okay, that is the rule. And for 14, it looks like this. And the rule is x negative y. Okay, so that's one of the homework problems, the worksheets that you were supposed to turn in. It's too late to turn it in now, especially since I'm giving you the answers. For It's Your Turn worksheet, how do you turn them? This triangle turns clockwise and looks like this, 90 degrees. This one turns clockwise and this rectangle looks like this. This little shape goes down here and looks like this. For number 4, this like arrow thing or rocket thing goes like this. 180 degrees, this little T goes like that to like that. And then the 6, this triangle rotates around the point that's on the triangle. So it rotates like that. So that's the answers to those. The other worksheet that you had to do was, this one's pretty easy. This had 2 lines of symmetry, diagonal lines of symmetry. This one had 1 horizontal, 1 vertical, diagonal, diagonal. These 2 didn't have any. There's no line of symmetry for this one or this one. And these all had 1 kind of right down the middle. So very easy worksheet to do and turn in. The other worksheet, reflect on this. These are all the reflections, across the lines. These 2 lines were diagonal, and says the hint, if the line of the reflection is not horizontal or vertical, rotate your paper. So if you like turn your paper 180 degrees, you can see that it's going to be over here. If you turn your paper 180 degrees, it's going to be over there. Okay. Next, so that was your other. So those are all the homework assignments, the answers. They were due today. So you want to click on today's homework later on. You're going to do Delta Math. We can do it at the end of class if we have time. But we're going to get started with today's notes. So let's go to, if you have your books open to 321, that's where we're starting. And actually, this is not the beginning. I need to go back. So 321 math notes, vocabulary for expressions. Okay, so we're going to take some vocab notes right now. This should be in the notes section of your book, right? Because this is a math notes. But you do want to submit it as part of your classwork for today. So let's write 321 math notes, vocabulary for expressions. Okay, so that's the first thing you want to write down. Give you a second to do that. 321 math notes, vocabulary for expressions. Okay, what is a mathematical expression? A mathematical expression, and you want to write some of this down. You're not going to write all of this down, but whatever you think is important, go ahead and write down. An expression is a combination of numbers, variables, and operation symbols. So numbers, letters, and plus and minuses, or division, multiplications, right? If we add, the addition sign or subtraction sign separates the expression called terms. For example, go ahead and write this down. 4x squared minus 3x plus 6, right? That is an expression. And how many terms does this have? This has 3 terms, right? How do we know the terms? Because they're separated by a minus and plus. So the first term is 4x minus squared. The second term is 3x. And the last term is 6. Okay, so that is what we mean by terms. That's what an expression is. This is a mathematical expression. We're going to learn how to multiply 2 mathematical expressions today. Okay, and then the term at the end is called the constant term, the one that just has a number at the end. That is called a constant term. Let's write that down. And then we need to know what coefficients are. I think I cut off coefficients. Coefficients, let's write that down. That's important. Coefficients are the numbers in front of the variables, right? So like 4 is your coefficient here. -3 is your coefficient. So our coefficients are +4 and -3 for this problem here. 6 does not count as a coefficient because it's a constant term. Okay, so 4 is a coefficient of x and -3 is a coefficient of x. So those are our coefficients. And now you know what a constant term is, and this is a mathematical expression. Okay, when you have several mathematical expressions, it's called a polynomial. A one variable polynomial is an expression which only has terms of the form any real number x to a number. So like 3x to the 5th power, right? And we could add more, plus like 5x to the 2nd power. This is a polynomial. When you put several, it's an expression, but poly means many, right? So it has many terms, So please write down polynomial. Polynomial is an expression that has many terms, and many could be 2, could be 3, could be 4, could be 5. We could keep adding on to this. We could do plus 2x minus 6. This is a polynomial, right? And we're going to learn how to factor polynomials. We're going to learn how to do lots of things with polynomials. In math 3, we're factoring polynomials right now. In math 2, you factor polynomials. So do it in both math 2 and math 3. Okay, so here's some more polynomials. What is a monomial and a binomial and a trinomial? Those are important. So a monomial is a polynomial. Mono means one, right? It means it has one term. So go ahead and write that down. A monomial is a mathematical expression with one term. So like here's an example of a monomial at 15y squared. Or just -2. That's also a monomial. Okay, both of these are monomials. They only have one term, even though there's two things here, a coefficient and a variable. It counts as one term because there's no plus or minus in it. This is one term because it's just a constant term, -2. Okay, so that's a monomial. These are two examples of a monomial. What is a binomial? A binomial has two terms. The prefix bi means two. So two terms. A binomial has two terms like this, 16m minus 25. Example, 16m minus 25 is an example of a binomial. Okay, another example they have here is 7 or 7h to the 9th power plus 1/2. That's a binomial. We have two terms. Okay, and lastly is a trinomial. You can guess how many terms a trinomial has. Feel free to unmute yourself and say the answer. Okay, so trinomial, prefix tri means three, so it has three terms. So here's an example of a trinomial, which we're going to do a lot in Math 2, Math 3. We're going to deal with trinomials. You're going to learn how to factor these, a super important skill. So here's an example of a trinomial. Let's write the first one that's here. 12 minus 3k cubed plus 5k. That has 1, 2, 3 terms, right? 1, 2, 3 terms, all separated by a minus and a plus. So 1, 2, 3 terms. That's a trinomial. Here's another example of the trinomial. Right here, the x squared minus 15x plus 26. And this is how we like to see trinomials in descending order, with the highest power first, the next power x to the first, and then no power. The constant always goes at the end. So this is proper standard form of a trinomial. 1, 2, 3 terms. Trinomial, super important. Okay, so now you know what a monomial is, you know what a binomial is, you know what a trinomial is, and you know what a mathematical expression is. And today we're going to learn how to multiply mathematical expressions. Okay, so this goes in your math notes. Now we're going to go to classwork, so separate piece of paper or different part of your notebook. I'm going to clear out this writing. If you need to take a screenshot, do so now. I got to clear the screen, so it's going to go away. Take your screenshot if you need to. All right, next slide. We have 84. So first problem that we're going to do is 3-84. And these are what we call area models, right? So let me get my pen back. Let me change it to blue. Okay. How do we use an area model to multiply expressions? Or in other words, to find the area, or we could find the perimeter. I'm not going to focus on perimeter a lot today. I'm going to do more area because we're doing area models. Okay, so how do we multiply? Let's say we want to multiply this. Go ahead and write this down. Y plus x plus 2 times x plus 4. I want to multiply this trinomial times this binomial. Okay, and this is the area model for it. So if you have time, like just do a quick rectangle, you know, make 1, 2, 3. There's 4 columns here. Make this one bigger, label this one XY, this one Y, and this one X. Okay, so if we do that, we have lengths along here. If you remember our tiles from last year and 7th and 8th grade, the shorter side is X, so I'm going to write X there. The longer side is Y. Okay, in the tiles, just that's the tiles that we use. So the shorter side is X, the longer side is Y. Since this is a shorter side, this is going to be an x. This is basically an x squared, right? Because it's x times x, so that tile's an x squared. This is, the length is x, and this would be 1. The small sides are 1. So if I were to add this length up, I would get y plus x plus 2, right? Y plus x plus 2, which is right here. So that length represents this expression right here, y plus x plus 2. Now, if I do the width here, you know, I've got an x here, and I've got little ones, units, 1, 2, 3, 4. So this is 4. So this side would be x plus 4, and this would be the area model for this. Okay, well, we want to multiply this out, or we can count how many tiles we have, right? If I were to multiply this, I would go like, hey, this y times this x, this y times that 4, this x times that x, this x times that 4, and then this 2 times this x, and then this 2 times 4. And that would give me 6 multiplications that I would need to do. And that's how you would do the problem without an area model. But if I wanted to use the area model, I would add all the tiles together, right? How many XY tiles do we have? We have 1 XY tile, okay? How many X squared tiles do we have? We have 1 X squared tile. Then we have a bunch of these little skinny tiles, which these are all Y tiles, right? How many Y tiles do we have here? 1, 2, 3, 4, right? So we have 4 Y tiles. And then we have these little tiles right here. These are not Y tiles, these are X tiles. So that's an X tile, X tile, X tile, X tile. And then we have 2 more X tiles over here. So we have how many X tiles over here? 4 X tiles. And then we have 2 X tiles over here. So if I add 4 plus 2X, that gives me, we have 6 X tiles here. And then these are little unit tiles. They all count as ones, right? Like this is 1, 1, 1, 1, 1, 1, 1, 1. How many one unit tiles do we have? We have 8 little unit tiles, so plus 8. So we say that the area of this figure is this expression right here. XY plus X squared plus 4Y plus 6X plus 8. If I were to multiply these two, this trinomial by this binomial, I would get this polynomial and use the area model, right, to get that. Okay, so let's do another one here. This is number 85 in your book, 3-85. It's 4x plus 5 times, sorry, that messed up a little bit, times 2x plus 3. How do we multiply that? Okay, so 4x comes from, hey, this side is an x, this side is x, and this side is x. If I multiply x times x, I get x squared, right? That's an x squared tile. Here's another x, here's another x, here's another x. Same length. That's an x, that's an x, that's an x. How many units do we have here? 1, 2, 3, 4. So we have 5 little unit tiles. So this length is 4x plus 5, right? Which is this expression right here. Now, if I do the width, you know, here's another x times x. If I multiply x times x, here's another x squared. So that's an x squared, that's an x squared, that's an x squared, this is an x squared, that's an x squared, this is an x squared, that's an x squared. Well, we'll talk about how many x squares we have here in a second. And then we have 3 little units. So this is plus 3, right? So the width here, we have 2x plus 3. That would be this expression right here. So your width is 2x plus 3, your length is 4x plus 5. We're doing length times width, right, to find the area of any rectangle, and this is a rectangle. Well, let's count how many x squared tiles we have. We have 8 of them, right? There's 8 x squared tiles. And then let's count how many of these there are. What are these little skinny tiles? Are they x's? Are they y's? What are they? Oh, that's an x tile, x tile. These are all x's, right? So how many of them are here? We have 3 times 4, so that's 12x. And then here are more x tiles, right? And I have what? 5 times 2, so there's 10x here. So I want to add 12x plus 10x is 22x. And then we have our little unit tiles over here, right? So how many unit tiles do we have? 3 times 5 is 15. So if I were to multiply out 4x plus 5 times 2x plus 3, it would give me 8x squared plus 22x plus 15. Okay. So that's how you do it using the area model. Do we want to use the tiles every time? These are called tiles, right? First of all, you guys don't have a bunch of tiles. You can draw these out every time if you want to, but that would take a lot of time. So there's a faster way, right? So this is what we're going to do. Go ahead and draw this little rectangle right here. And since this is 2x, I'm going to make it like this long. And since this is 4x, it's like twice as long. I'm going to make it longer. It's not exactly to scale, but you know, it's longer than this side. So this side is 2x. So instead of doing all the little tiles, I'm going to say, hey, this is 2x, this is 4x. And then this part, I'm going to make your plus 3. And this part, I'm going to make your plus 5. It's going to be a little longer because it's more than 3. Well, can we multiply these two to get our numbers inside, right? What's 2x times 4x, you guys? 2x times 4x. Doesn't that equal 8x squared? So can't we just write that inside there? And you can go ahead and write that inside your little rectangle. This is called the generic rectangle, okay? Rectangle. And then to get this number over here, I'm going to multiply this length times this width. So what is 3 times 4x? 3 times 4x, that's 12x. So that's the area of that little part right there. To get this area, I'm going to multiply this length times this width, right? Or in other words, I'm going to multiply 2x times 5. Well, 2x times 5 is 10x. So that's what goes in that area, and that's the area of that part of that rectangle. And then lastly, we want to get the area of this rectangle. So I want to multiply, I'm going to change my color really quickly here. I'm going to multiply this part, this 3, right? I need to multiply this length times this width. So 3 times 5. 3 times 5 is 15. Okay. And then we're going to take all these pieces and add them together. If I take them and add them together, I'm going to change colors again. First, you start with the big tile, the 8x squared. Okay. Then you do these two that are diagonal to each other, the 12x and the 10x plus, I'm going to add those together. What's 12x plus 10x? That's 22x, right? And then you do the constant last. Remember, the constant goes last. It goes at the end, 15. So we use this generic rectangle to multiply binomials, right? And that's what we're going to start doing today. So instead of doing all the tiles, we're just going to do a generic rectangle for every binomial times binomial or trinomial times this one. If I wanted to make a rectangle for the top one, which we do, I'm going to make it longer. This is going to be a 3 by 2, right? I'm going to go 3 by 2. Why am I going 3 by 2? Because how many terms does this have? Y plus x plus 2. Y plus x plus 2. That's why I made it 3, right? And I want to multiply it by x plus 4. So x plus 4, like that. And then to get my numbers inside, I'm going to multiply it. What is x times y? xy. Then to get this rectangle, I'm going to multiply what is x times x? X squared. To get what goes in here, I'm going to multiply x times 2, which is 2x. Right? Then I'm going to get what goes up here, so I'm going to multiply 4 times y, which is 4y. Then I'm going to get what goes up here, so I'm going to multiply 4 times x, which is 4x. Then I'm going to get what goes up here. I'm going to multiply 4 times 2, which is 8. Some of these are going to be like terms that you're going to be able to combine. These are like terms, right? So I'm going to add those together. These are not like terms. This is not a like term. They have different letters. So my answer is going to be, I'll start with this one, xy plus, I'll go x squared plus 4y plus, I'm going to add these two, 6x plus 8, right? So I use this generic rectangle to get the same answer that we got over here. If the terms are in a different order, that's okay. I happen to put them in the same order here. As long as all 5 terms are there, then it is okay. Okay, so that is how we use generic rectangles to multiply a trinomial times a binomial. All right, I got to clear this screen away. So if you need to take a screenshot, I'll give you a second to do that. All right, next screen. 87. Go ahead and write 3-87 in your papers. 3-87. Copy each of the rectangles below onto your paper and write the area of each rectangle as a product equal to its area as a sum. So we want to write a product means a multiplication problem, and a sum is an addition, answer to addition problem, right? So go ahead and copy this down, right? So for A, we have this rectangle. It's a 2x2. And we have 2x plus 3. And we have, it's supposed to be x plus 5. Yeah, I think this is supposed to be x plus 5. It's just not written well. Okay, what is the product? What are the 2 things we're multiplying? Well, we're multiplying this 2x plus 3 times this, right? X plus 5. So that is our product. We took care of the product part. And we want to make it equal to the sum. Well, the sum is the sum of the parts here. So we have to multiply this out and add them together. So what is 2x times 5 going to give us, guys? 10x, right? And then what is 2x times x going to give us for this rectangle here? 2x squared. And then for this rectangle, we're going to multiply 3 times 5, which is 15. For this rectangle, we're going to multiply x times 3, which is 3x. Okay, so we want to add these together. Okay, so start with the biggest term, okay, the x squared, the 2. I'm going to start with that one. So I'm going to put 2x squared. And then I'm going to add these 2 together, the diagonal ones, because they're the same. What is 10x? What is 10x plus 3x going to give us? 13x. And then lastly, we'll put the constant term 15. Okay, so this is our sum, and this is our product. Product, sum. You need to have both. You have to tell, hey, what 2 things are we multiplying? This is what they come out to be when they multiply, when we add the parts together. This is the sum of the parts. Okay, so product equals sum. When it says write the product and sum, you need to write both. Don't just give me the sum. A lot of people would just give me the answer and they won't give me the product part. You have to put both. Okay, let's do part B here. Part B, we're only multiplying a monomial 3 times a binomial y plus 5. So I need to split this in half to make 2 by 1 square, right? Because this is 2 terms, this is 1 term, so 2 by 1. So 3 times y is going to give me 3y. 3 times 5 is going to give me 15. If I add these together, so what is my product and my sum? What 2 things are I'm multiplying? Multiplying 3 times y plus 5, that. Multiplying this times this, and it equals what's inside the rectangles, 3y plus 15, right? And can't we just use the distributive property? Can't we just like multiply those 2 like that to get that, right? That's all this is. So again, this is my product. This is my sum. Okay, you have to write it like this on the test. Okay, next problem here. Let's go ahead and write this rectangle. This is a 2 by 3, right? 2 by 3. 2 by 3. And hopefully you're using the squares on your graph paper correctly. I'm not exactly using them correctly, but 6y, I am using them though. It's funny to me when people use graph paper and they don't use the lines. They don't use the lines to make their rectangles. 6y plus x plus 1. So we have 1, 2, 3 terms. And then we only have 2 terms over here, 4y minus 7. So let's write what our product, what are we multiplying out? Okay, I'm going to put my binomial times my trinomial. So my binomial is 4y minus 7, right? The trinomial part is 6y plus x plus 1. That's what we're multiplying, right? I'm multiplying, really, I'm going to multiply this times this, all three of those, but we're not going to do it that way. We're going to use our rectangle to help us organize our work. Okay, now I want to do the sum. So to do the sum over here, I got to fill in the rectangle. So what is 4y plus 6y going to give us? 24y squared, right? Then I want to get what's in this rectangle. So I'm going to multiply -7 times positive 6y, it'll be negative 42y. Then I'm going to multiply these two right here to get this rectangle. So 4y times x is 4xy. You want to put your letters in alphabetical order when there's two letters, okay? And then for this rectangle, I'm going to multiply the -7 times the positive x, which would be -7x. For this rectangle down here, I'm going to do 1 times 4y, which is positive 4y. And then for this rectangle, -7 times positive 1, which would be -7. Okay, so now we need to write these 6 things down here, and we want to combine like terms. Okay, you always want to combine like terms. That's an important phrase, right? Terms that are the same. I'm going to circle the like terms. Let's see, which ones can we combine? I see this one, and unfortunately it's not directly across from it. Those two are like terms, right? And I don't see any other like terms. This has an x, this has xy, this has a y squared. Those are not like, none of them are the same, but these two are the same, so we can combine those. So first we'll start with the biggest number, 24y squared. Okay, then let's go ahead and add the 4xy plus 4xy. Let's go ahead and add these two together. What's -42y plus 4y? All right, I got to subtract these because these are opposite. So that'll be 38. So -38y. So we have -38y. Then we have a -7x right here, -7x. And lastly, the constant term is -7. So we have a big polynomial for our answer. We have 5 terms, right? We have 1, 2, 3, 4, 5 terms. We would have 6, but these two combined to be your 38y. Okay, so this is our product. This is our sum. Okay, next, how do you multiply this? Oh, this one's pretty easy. What do we have? 2x times x. What is 2x? So our product is 2x times x, right? That's our product. That's our product. What's our sum? What is 2x times x? Well, 2x squared. So the answer is 2x squared. So when we multiply 2x times x, we're going to get 2x squared. That one's pretty easy, a 1 by 1, like those, monomial times monomial. Okay, I'm going to be going to the next screen. So if you need to take a screenshot, go ahead and do so. Clear this out. Go to the next slide, slide number 4. Okay. So they want us, so this is number 97. They want us to multiply these using the generic rectangles length and width. Okay, so get my pen back. Okay, so 3-97. So if I were to do, let's write down a, x plus 3 times 2x plus 1. Make a generic rectangle. It's a 2 by 2, right? So I'm going to go something like this. So I could put the x plus 3 over here. I'm going to put the 2x plus 1 over here. I like to put the bigger number since this is longer. I'll put the 2x plus 1 over here. And then the x plus 3 is going to go like that. Okay, that is how you set up your rectangles. This is what I need to see on your paper. This is the work I need to see, okay? So what goes in here? 2x times x is 2x squared, okay? What goes up here? 2x times 3 is 6x. What goes down here? X times 1 is 1x. What goes up here? Positive 3 times positive 1 is 3. Okay, always look for like terms. Here, these two are like terms. They're usually going to be diagonal like that. Okay, so what does this times this equal? It equals, let's start with the biggest term, the 2x squared plus, let's add these together, 6x plus 1x is 7x, and then plus 3. So this is my product, this is the sum, right? So I'm going to put a box around the sum. That's our answers. That's our answer. When we multiply this times this, we get this. Okay. When you have a problem like B just says 2x times x plus 5. You know, we could do like a little 2 by 1 if we want to. We could go boom, boom. I could do, x plus 5, 2x like that if I want to. Or we could just use distributive property. Let's go ahead and use distributive property. What's 2x times x going to be? 2x squared. What's 2x times 5 going to be? 10x, right? So that's all you have to do when you have a one expression outside of parentheses. You just need to use the distributive property. You can do this if you want to. Go ahead if you feel like it, okay? I'm going to set up D and E for you, okay? And you guys can do the rest, okay? I'm not going to do all these because there's a lot more slides we need to do. So make sure you leave a space for C, okay? Leave a space for C. For D, we're going to do 2x plus 5 times x plus y plus 2. Okay, so this is a 2 by 3, right? We have 2 by 1, 2, 3. So we need to make a 2 by 3 box. So I'm going to go, hey, this is a 2 by 3. 1, 2, 3, right? So the 3 is going to be on the bottom, x plus y plus 2. My binomial, 2x plus 5, I'm going to put over here. Then we're going to multiply and fill them in. Okay, so what is 2x times x going to give us? 2x squared. What is x times 5 going to give us? 5x. For this rectangle, what is y times 2x going to give us? 2xy. For this rectangle, what is 5 times y going to give us? 5y. For this rectangle, what is 2 times 2x going to give us? 4x. For this rectangle, what is 2 times 5 going to give us? 10. Okay, so when I multiply this times this is my product. What is the sum? The sum is going to be all these parts. We start with the biggest one, which is usually going to be here on the bottom left. 2x squared. Can we add these two together? No, because this has a y. Can we add these two together? No, but I do see two that we can add. We can add this one and this one, right? Those are the same. So first I'm going to go to this one, plus 2xy. I'm going to go ahead and put the plus 5y in there. Plus how many x? What is 5x plus 4x going to give us? 9x. And then lastly, plus 10. So unfortunately, I can fit that all in one line, but I have 5 terms here. Okay, so those 5 terms are the sum of when we multiply this times this, this times this, this times this, this times that, this times that, this times that. This is what we get. Okay, so we're multiplying a binomial times a trinomial. The other one I want to show you is this right here, E. Okay, the other ones you can do on your own really easily. E, 2x minus 1 squared. Okay, a lot of people think that you're just going to square this and get like 4x squared minus 1. That is wrong. Okay, and why? To see why, we have to make a binomial times a binomial square. Right? 2x minus 1 squared means 2x minus 1 times 2x minus 1, right? When you square something, you're multiplying it by itself. Well, there should be 4 multiplications here. If you just distribute like this, you only have 2 things, but you need 4. So you can't distribute over subtraction like this. You can't distribute a power over subtraction or addition ever. You can't do that. So let me erase that so that you don't think you can do that, okay? Go back to my drawing pen. Okay, so how do we do this? We go 2x minus 1 times 2x minus 1, right? And we multiply it out. 2x times 2x is going to give me 4x squared. When I multiply negative 1 times 2x, I'm going to get negative 2x. Well, I should get the same thing right here because I get negative 1 times 2x, which is negative 2x. And then for this one, I'm going to multiply negative 1 times negative 1, which is positive 1. And again, these diagonal ones are going to be like terms. They're going to combine them. But let's go ahead and start with the big one first. 4x squared. Combine these two. Minus 4x, because negative 2x plus negative 2x is negative 4x. And then lastly, plus 1. So look, I didn't just get 2 terms. I didn't just like square that and square that. You can't do that. It's not just 4x squared minus 1. It's 4x squared minus 4x plus 1. Okay, so that is E. I'm going to clear the screen. So if you didn't get it all, make sure you do a screenshot. Okay, 97. And actually, you know what, you guys? I am going to do a quick pause here just for a stretch break. So I'm going to pause my recording. Okay, so for 97 here, we want to multiply all these, but you know, we're not going to multiply. It's just more of the same of what we were doing. What I wanted to do, it says, then write an equation showing the area written as a product is equal to the area of the sum. So product equals sum. Sketch an area model. Oh, this isn't the one. Did we do this one? This is the one we just did, isn't it? Yeah. So I need to go on to the next slide. So let me do that. I don't know why I didn't go into the next slide. We did that one already. Okay. Distributive property. So 98, let's look at 98 here. Says, hey, if you noticed a pattern, anytime you have like one term outside the parentheses, one term outside the parentheses, can't we just distribute like that? Boom, boom, distribute like that, distribute like that. So let's do these really quickly. Let's do A here, so 3-98A. Okay, let's do 2x times 6x plus 5. We could make a little box, but we don't need to because it's only got one term. So let's distribute. What is 2x times 6x, you guys? 12x squared, right? And then we just distribute, multiply it through, this is called distributive property, 2x times 5. And there's a plus here, so we're going to put plus 2x times 5 is 10x. So we can just use the distributive property if there's only one term outside. So I'm going to do C next. I'm going to skip B. C, x squared times 4x minus 2y. Okay, if there's just one thing, then I can multiply that one thing by everything in the parentheses, right? Again, this is called the distributive property. We distribute. X squared times 4x is 4x cubed. X squared times negative 2y. What do you do when there's an x and a y? You put the x's first, right? So 2x squared minus times y, like that. Okay. A second. Somebody's sending me a message in the chat. Okay. You're good, Crystal. You can send me a message later if you want to. All right. So that times that. Boom, boom. Okay, so very simple. When there's an x and a y, you just put the x first and the y after. You know what? Let's skip the D. I wanted to do D because this has a Y and it has an X and a Y. So just wanted to do that. D. 7y times 10x plus 11y. Turn off my camera too. I forgot to do that. Okay. So distribute. What is 7y times 10x? So you multiply the number part first. 7 times 10 is 70. And then you put the letters in alphabetical order. So since there's an X and then a Y, I'll put the X first and then the Y after. Okay. So 7y times 10x is 70xy. And then I'm going to multiply the 7y times the 11y. So 7 times 11 is 77. And then since there's two y's, a y times y is a y squared, right? So just simple distributive property. So we could do like a 2 by 1, but we don't need to. We just use distributive property for all these ones. Okay. So I'm going to go on to you don't have to do the other ones. I'm going to go on to 99 because we have 2 more problems to do. Then we're done. Yeah. Got to clear this away. So if you need to take a screenshot, do so. Next slide, 99. Okay, and I don't think we're going to do all these either. Does order matter when multiplying polynomials? Like is x plus 1 times 7x plus 1 the same thing as 7x plus 1 times x plus 1? Does it matter which one we put first? And it shouldn't, right? So this should be the same thing. So is x plus 1, go ahead and write this down, is x plus 1 times 7x plus 1, is that equal to 7x plus 1 times x plus 1? Are those two things equal? If I switch these around, is it the same thing? And the answer is yes, it is the same thing. So it doesn't matter which way you write it, right? Why doesn't it matter? Because isn't 3 times 5 the same thing as 5 times 3, right? You're going to get the same thing. You're going to get 15 either way. This has a special name. This is called the commutative property. So I'd like to write that down. Is it commutative or commutative? I forget, but I think it's C-O-M. It might be C-U-M. Commutative property. Let's say it's like that. Yeah, I believe that's right. Commutative property means that when you switch two things around, it's okay. The commutative property works for addition and multiplication. It does not work for subtraction and division, right? You can't switch a subtraction problem around. You can't do 3 minus 5 equals 5 minus 3. It doesn't work. That would be negative. So it only works for addition and multiplication. So since these are being multiplied, this is like our, let's say 3 times a equals a times 3, right? It doesn't matter if you switch it around. So because of the commutative property, it's the same. So instead of doing all these, we could do 2 by 2s for all of these. I could do more of that, but I think you get the idea. Let's just match the ones that are the same because part C says which expressions below have the same products. So take a second to copy these down. Go ahead and copy these down. Okay. So number 1, Roman numeral 1 is x minus 5 times 2x plus 3. Go ahead and copy that down. Roman numeral 2 says 5 minus x times 2x plus 3. Are those the same? No, these are not the same. X minus 5 is not the same as 5 minus x, right? Like I discussed up here. So these two don't go together. 3, let's go ahead and write down Roman numeral 3. 2x minus 3 times x plus 5. Go ahead and write that down. 2x minus 3 times x plus 5. 4, let's go ahead and write number 4 down. 2x plus 3 times x minus 5. Would these two be the same? 2x minus 3, 2x plus 3, x minus 5, x plus 5? No, those would not be the same, right? They would not be equal. Okay, so you're writing these down. Go ahead and write down 5. 2x minus negative 2x plus 3 times x plus 5. Is that the same as 3 or 4? I don't think so, right? Can we switch these around? No, that's not the same. So, but we'll write it down. let's write down number 6. Negative 5 plus x times 2x plus 3. Roman numeral 6, VI. Negative 5 plus x, 2x plus 3. Is that the same as one of these over here? It is the same as one of them. We'll see which one in a little bit after we copy the last two. Let's copy number 6, Roman numeral 6. Negative x plus 5 times 2x plus 3. Is that the same as this? No, right? You can't switch the subtraction problem around, so that's not the same. But maybe it's the same as another. Oh, it is the same as one of the other ones, I think. And how about this one? Roman numeral 8. 2x plus 3 times 5 minus x. Is that the same as one of the other ones? It's backwards of this. Is that the same if this is backwards from that? Is subtraction commutative? No, that's not the same. Okay, so let's match the ones that are the same. Some of these have matches and some of them don't. I noticed, let's see, 2x plus 3. These are not the same, right? 5 minus x is not the same thing as x minus 5. You can't switch those around. So those are not the same. But I remember this one was the same as one of the other ones. Which one does this go with, guys? If I reverse this, right, how would the negative 5 plus x, how could I rewrite that? That could be x minus 5, right? If I switch this around, that's x minus 5. So that one goes with this one. So number if you wrote all these down, you could draw an arrow like that. I'm sorry, just I goes with VI, right? So these two go together, I and VI. Okay, number 1 and number 6. I think there was one, is there the one the same as this? I don't know. This one I think had a match. Did this one have a match? No, because there's a negative in front of the 2. I don't think there were any other negatives in front of the 2x. So that one didn't have a match, right? No match. This one, if I rewrite this, right, if I rewrite negative x plus 5, isn't that the same as this, right? If I rewrite this, that's 5 minus x. If I switch these two around, that's 5 minus x. So those two go together. Okay, so number 6 goes with number 2, I. Okay, so those two go together. And there was one more that went together. Let's see, 2x plus 3, x minus 5, 2x, this one, 5 minus x. This is the same as this, isn't it? Like if I switch this around, this is negative x plus 5. If I switch these two around, this is negative x plus 5, which is the same thing as this. So VI, II, and VIII, and 8. These three go together. This one, those are the same. Okay, I think that's it. If I missed one, you can add it in there, but I think those are all the ones that are the same. You know, if we want to, we could do what they want you to do is to do rectangles for all of these and see which one has the same answer. I'm not going to make you do that just because that would take a long time. So I just matched them up by what was the same when we looked at them. And 2x minus 3, I don't think this one has a match, right? Yeah, no. Okay. So one more, uno más. Let's go to, I'm going to erase this. So if you need to take a screenshot, go ahead before I erase it. All right, let me erase that last slide, 100. You guys are being troopers. I appreciate it. I really appreciate you guys' patience and just learning, trying to learn. We're all trying to learn here, trying to better ourselves and get more math knowledge. All right, area model puzzles. Copy each of the area models below. Okay, so we have some missing blanks here. So we're going to copy these down and then you have to fill them in. You have to fill in the blanks. It's like a puzzle, right? That's one thing I love about math. It's just a big puzzle. So 3-100. A. Gonna just do an XY and a 3Y. So they filled in the box here for us and they filled in this length, but they didn't fill in this side. and they didn't fill in this side, or maybe we're writing it over here. So we're missing this side and we're missing like what goes over here, right? Well, what would you have to multiply x by, right, to get xy? Well, you'd have to multiply by a y. So there should be a y over here, right? And what would we have to multiply right here, these two, to get 3y? You have to multiply y by 3. And that's a plus. So those are the two things that are missing. So you have to fill in like the parts around the box. Okay. So we'll do B next. B, we have, we're doing the right side just because they're not leaving room over here. I mean, I could do the other side if I want to. Oh, that is a terrible box. Okay. So we're doing plus 5 here. We're doing 12x here and x squared here. Copy each other. I feel like well, if this is x squared, what do we know? And I want to put my values here and here. What two things do you multiply to get x squared? There's only two things you can multiply to get x squared, right? What is that? X times x. So those have to be x's. Now that'll help us fill in right here. What do we multiply x by to get 12x? 12. So a 12 goes there. And then to get this, what is 12 times 5? That's 60. And then to get this box, let's multiply our 5 times our x, which is 5x. So that one was interesting because at first I didn't think we were going to be able to solve it because we didn't have enough information. But the only way to get x squared is to multiply an x by an x. So that's the key to doing that one right there. Then write okay, so write a product and sum. So what are we writing? They do want us to write a product and sum. Make sure you read product, sum. So our product we're multiplying is x plus 5 times, go ahead and write this as x plus 12, okay? X plus 12. What does that equal? It equals, start with the x squared, add these two like terms together, 12x plus 5x, that's 17x, and then plus 60. Okay, so this is our product sum. Product sum. Okay, so let's do C here. C. Boom. It's 2 by 3. Terrible rectangle. Whoa, that's pretty bad. All right, so -2 here, -4x here, -3y here, -3xy here, and -10 here. And I remember something like this on the test from last year. If you remember last year, we had something like this on the test. So you need to fill in what goes here, what goes here, what goes here, what goes here, here, and here, right? So we have to fill in all the blanks, and there's blanks outside the box. Well, we'll start here. It's kind of like Sudoku, if you ever played Sudoku, right? What's -2 times what equals 4x? Well, we're going to have to multiply 2x, right? 2x. Because -2 times +2 gives us -4 and then an x. Well, we don't know what goes here yet, so we need to, but we can figure out what goes here by looking at this, right? We have a -3y here. What would I multiply -3y by to get -3xy? Well, that would just be an x, right? This times x would give me this. So now I can go back and multiply these two to get this square. X times 2x is 2x squared. And now I can fill in this blank. -2 times -3y is +6y. I can fill in this by looking at this. -2 times what is -10? That would be +5. So that's a 5. And then 5 times x gives me what goes here, which is 5x. So let's write our product sum, right? Our product sum. So our product is, put the binomial first, x minus 2 times our trinomial. Our trinomial is 2x minus 3y plus 5. That's our product. Those are the two things we're multiplying. What's the sum? The sum is what's inside. So let's start with the -2x squared. -2x squared. Then I'll do these two, minus 3xy, then plus 6y. And I see a like term in here, right? I see negative 4x and positive 5x. What is negative 4x plus positive 5x? That's 1x, right? Positive 1x. So I'm going to put a plus x. And then lastly, the constant always goes at the end, minus 10. So that is our product sum. Product sum. Our last one. Here, let's see if you guys can do this. I'm going to put it up and you guys finish it, okay? We'll write it together and you guys finish it. And then we'll explain our delta math homework. X squared, 6. There's an X out here and that's it. Erase my little dot that I made here. You guys do it. Try it. I'm not going to do it. You do it. So you fill in that part, you fill in this part, that part, and those two boxes. Are you guys able to do this? Let's see. I know an X goes here, right? Or X times X. You know what? There could be multiple answers for this. For this 6, what could we put? So there are actually several answers for this. What could you multiply to get 6, guys? What could we put here and here? You could put, okay, you could put 2 and 3, or you could put 1 and 6, but let's just say we put 2 and 3. If we put 2 and 3 there, now you should be able to fill in that box and that box. And then go ahead and write your product and your sum, okay? Or the other answer would be, you know, you could put a 1 and a 6 here instead, and then your answer would be a little different, but that's okay. So just do the 2 and 3 and write your answers in there. Give you a minute to write that down before I switch to the Delta Math assignment. Okay, so that's the classwork. You guys are going to take pictures, hopefully be able to submit this as a PDF or as separate pictures. I don't care if you put separate pictures either. PDF is a little nicer. I'm going to clear all this out and show you what your Delta Math assignment looks like. Okay, so clear all drawings, Delta Math. Where's your Delta Math? Oh, actually, if you go to, where's my Delta Math? There it is. Okay, so here's one of the problems. Hey, so I could use a generic rectangle, right? I couldn't see your work but on your paper, you'd want to make a 2 by 3 and type this in. How do you do cubed or squared, guys? Shift 6, right? So when I multiply negative x times positive x squared, I'm going to get negative x cubed. So you do shift 6, right? Shift 6 will put an exponent. I'm going to put to the third power like that. So negative x to the third power. And then there's going to be a whole bunch of other answers. I'm going to type, I don't know, like I'm just going to pretend I'm going to put plus 2x, you know, squared. So shift 6 squared. This is totally wrong. I'm just guessing. And there are more answers, you know, minus 3x minus 5 or something like that. This is going to be wrong. I'm just going to put it in just so you can see, right? Do I want to submit my answer? Yes, I'm going to submit this wrong answer and get it wrong. That's okay. It's going to show me what I did wrong, right? So, hey, this is what you should have on your paper. You should have this generic rectangle on your paper and check your work. And then this was the correct, oh, I was kind of close. Look at that. So you want to use it to correct your work, right? Use this to correct your work. So you get 3 tries. So now I can try the next problem, right? I could do it again, submit another answer. So you get 3 tries for each problem. and there's only 6 problems to do. So you have 1, 2, 3, 4, 5, 6. And you have to pass them 3 times. So I passed this one once. I failed that one that I just did somewhere over here. I passed this one twice. It does not take long. Okay, so I want you to start on this. Okay, we have like 15 minutes left. I'm not going to keep you on, but I am going to grade your assignments, guys. So here, let me show you what your assignments look like. Do I want to pause my recording here? Let me pause my